of the forgot to record. So a reason it's large is because a lot of the content is split across triangles, and there are a lot of things, right? So, but if you look at the content, it's kind of fairly uh, what do you say, precise. It's not very strewn out. So 1 minute, let me just start my slideshow. Perfect. Yeah, I hope you guys can see my screen.
Yes.
All right, just hold on, let me just. All right, so today uh I've allocated 90 over here because I generally tend to go over the limit, but the idea is to complete it within 60 minutes, right? So, Ankur, if you remember, in our last class, just starting off where we left off, we looked at all the factors that affect the development factors, right? All the things that affect the development factors. I hope you were
Yes.
able to go through and uh, look at the mnemonics again, right? And let us kick off where let us start from where we left off, which is the all the things that affect all development factors, right? So I'm going to reiterate
Right.
this because and I do this because it's going to be very important. You have to understand this, and this is something that I want you guys to get memorized, right? So memorize this because this is something that you can use across the table. It's not just factors that influence development factors. It is also factors that influence reserves at the end of the day, right? So this is something that can be plugged across the value chain of reserving, and these give you viable marks, right? So these are all mark generating points. So if you know claims handling as a point, right? And if you've memorized claims handling as a point, you can plug that across multiple things. And generally, when you memorize it, you'll be able to recall it during the exam, which gives you that additional edge rather than see it and kind of takes a little bit of the visualization away. So factors that impact development factors. The mnemonic is small spherical dice. M is for mix of business impacts development factors, right? The changes in business mix will change your development factors. Average policy length impacts development factors. Large claims and catastrophes impact development factors. Seasonality of claims impacts development factors. Propensity of customers to make a claim. If customers start making more claims, you will start seeing more claims incurred, which automatically changes the development factors, right? If customers start making larger claims, it increases the severity, which means you will start seeing higher paid claims, which again changes the development factors. Claims handling. If claims handling becomes tighter, for example, right? If they become tighter, lesser claims will get reported or lesser claims will get accepted, even though they are reported because claims handling has been tightened, which will again impact your development factors. Claim reviews. If there are more frequent claim reviews, it basically means that there'll be more case reserve adjustments that are made, which could automatically impact and change your development factors. Recession and economy. Again, if there is 2008 kind of a crash, that will obviously impact your insurance claims as well, because the economy and the insurance claims aspects are both linked together, which again results in changes to your development factors, right? Changes to case estimates, changes to case reserves, again, impacts. Actuarial judgments, very important point for you guys to remember when you are dealing with any question related to reserving, because at the end of the day, reserving heavily depends on actuarial judgments, right? It is the judge, even the factor that is incorporated, even the factor that is selected is basically based on the judgment of the actuary who's selecting the factor, right? Why do you select a tail factor of 1.04 and not 1.05 or 1.07? The difference is minimal over there, right? But you do make a selection, and that is the importance of the uh, qualification and credentials that you have. So always remember actuarial judgments. Legislation, again another important point. Changes to legislation will automatically impact changes to development factors. Perfect example is, let's assume that there is no seatbelt law, and suddenly there is a law for mandatory seatbelts. Now, this will automatically reduce the frequency of motor claims, motor death claims, which will automatically reduce the severity, which automatically impacts the development factors when you're reserving for them, right? Market-wide initiatives, lack of data, and errors in data. So these are all factors. Please memorize them. Make it second nature to you. You have to be able to say this even in your sleep. If somebody asks you in your sleep, you have to be able to say these things, right? That's how you kind of get quick recall. Clear?
Yes.
So I can test you guys next time.
Yeah, we can try. Yeah.
Done. All right. Next time I'm going to test you guys. All right. So let's go. So multiple methods are there, right? Multiple classes. The most basic method, you guys should know it. Basic chain ladder method. So can you tell me how you go about with basic chain ladder method? Somebody?
Maybe I can go ahead.
Yeah, go.
So in basic chain ladder method, we calculate the development factors,
Okay.
then apply actuarial judgments to select the development factor which we find the most appropriate, which represents the trends.
Okay.
And then basis that so basically we calculate the cumulative claim triangle and then apply the development factor on the cumulative claim triangle to arrive at the ultimate claim amount.
Okay.
And then using that, we create the second half of the triangle.
Okay.
Just like a brief
No,
explanation.
that's a fair understanding of what the BCL is. Where can it be applied?
Applied in a sense
It can
in
be
the
applied.
claims triangle.
Yeah, it can be applied on claims data and premium data, by the way. You can apply BCL on premium data as well, because premiums also have earning patterns, which means you can split it into development periods, right? So you can apply it on premium data, you can apply it on claims data, and within claims data, you can apply it on both paid and incurred claims.
Paid and
right? So you have paid triangles, you have incurred triangles. You have incremental triangles and you have cumulative triangles, like you mentioned, right? Can you define what development factors are?
So development factors are basically year one by year zero amounts, right? So by how much the claim is developing over the period of time.
Okay. So official definition is cumulative amounts as at that development period divided by cumulative amounts as at previous development period. Right? If you're using cumulative triangles, if you're using incremental development factors, incremental amounts as at that period development period divided by incremental amount as a previous development period, right? What are the assumptions? What are the three main assumptions behind the BCL method? Quickly, three main assumptions.
That the past period is representative of the future claims. We can use the past period.
There is a better way of saying that, and the better way of saying that is the development patterns will remain appropriate in the future as well, right?
Yeah.
Second point.
Data that we are using the claims data is credible, maybe something on the data front.
Okay. Third point.
Any trend there, we do not fluctuation or inflation or any but that is something similar to the first point that I mentioned.
Okay, fair enough. Ankur, any idea? Can you take a stab at the assumptions?
I think the third one would be, I think, on inflation itself, that the past inflation is a good representative for future inflation.
Okay. And the second one?
So first, like she said, would be the same. And the second would be I would say the mix of business would fairly remain the same.
Okay. All right. So guys, just quick points. These are very important assumptions. Please memorize them. Please remember them, right? 3 assumptions. First assumption is that the development patterns are going to be consistent in the future. Past development patterns that have been observed are going to be consistent in the future, which basically says that your data is credible and stable, right? Your development patterns are stable. That's what you're saying. Second part is that the first cohort is fully run off, or if it is not run off, the ultimates can be easily determined using a tail factor. So if you just say first cohort fully run off, you will not get marks. You have to mention the tail factor as well, right? There are 2 assumptions over here. It's not just one assumption. If the first cohort is not fully run off, you can estimate the ultimates using a tail factor. That is the assumption. That's the full assumption, right? So if you just write first cohort fully run off, in if they ask you what are the assumptions behind the BCL method, let's say that there's a question, what are the assumptions behind the BCL method, right? And you say first cohort fully run off, you'll get 0 for that. You'll not get 0.5 marks, or you'll not get 1 mark, right? And the reason is that the tail factor is a very important aspect. Please memorize that. Please remember that. Third one is what Ankur said, which is future inflation is a weighted average of the past inflation, right? Unless, again, you can qualify this, unless explicitly stated. So why is that unless explicitly stated there? Because there are some chain ladder techniques where inflation index is used, right? And that's called the inflation adjusted chain ladder, which we will look at, right? So there's a reason why I'm giving this and not questions, because a lot of students have a lot of trouble even when it comes to understanding the assumptions, understanding the theory behind BCL, right? So today is just going to be an introduction, like I mentioned. This is how it's going to be, right? Now, when do you use chain ladder? So couple of points that you have to remember, right? You use basic chain ladder when there is sufficient data that's available. If there's no data that's available, you will not be able to, it will not give you good results, right? Now, the data should not only be available, it should also be credible, right? And there is also another criteria for the data, which is that it has to be homogeneous. So what do you mean by data has to be homogeneous? Can you guys tell me?
Belonging to similar cohort, like
Okay.
a
Not
similar
cohort,
characteristic, risk characteristics,
similar,
risk characteristics.
similar risks, right? So
Yeah.
many a times, your data will not have similar risks. And the reason for that is because within a same policy, there are multiple claim types. So a perfect example is motor insurance in India, right? A motor insurance policy in India can give rise to an OD claim, can give rise to a windshield claim, can give rise to a TP death claim, or a TP bodily injury claim, and a TP property damage claim, and a theft claim, right? And this is not accounting for catastrophe claims, whatever, right? And these are just 5 broad claims, right? It gets bucketed under OD, by the way. So these 5 claims are fundamentally different claim types. So if I'm reserving for the motor line of business, I need to have at least 5 triangles, because I have to split it by claim types. I can't reserve, or I can't create a triangle for, just TP as a whole, because the way that TP death claims mature and the way that TP bodily injury claims mature are wildly different. And let's not even go into TP property damage claims, which is again another universe. So you need to ensure that your data is homogeneous when you're doing a reserving exercise, right? Now, more important, not more important, chalo, as important as the data being homogeneous, is the data should also be consistent in terms of timing and content. I cannot have data for one line for the past 3 months and then have data for another line from the past 7 months or 8 months. That doesn't work. So that's because what happens in this scenario is that the development factors are going to start getting distorted when you don't have consistent data, right? So data being consistent, data being credible, data being homogeneous, sufficient data is available. These are all assumptions that you can actually make when you're writing exams. So if they tell you state your assumptions, these are some of the assumptions that you can talk about. So if you are selecting basic chain ladder, it means that these are met, right? So if they tell you, state the assumptions that you make apart from these three that are there on the left that you see, right? These are additional assumptions that you can write. And remember that at least 20 to 30% of a calculation question, the marks, 20 to 30% of the marks will go towards assumptions. So if you have a 10-mark question, you can safely assume that 3 marks will be 2 to 3 marks will go towards assumptions. So if your assumptions are spot on, you already got 3 marks, right? So even if you mess up the question, the fact that your assumptions are common sense and the fact that your assumptions are good will fetch you 3 marks, which means that you can safely get like say 6 marks or 7 marks, even if you get the answer wrong, right? So just these are all the points that you have to remember when you're writing, right? Now, what are the issues? Can you guys say, before we go to the next slide, can you guys say what the issues that you face when you would have probably run BCL methods, Ankur and Unnati, you would have definitely run BCL as part of your reserving exercises that you do, right? So what are the method? What are the issues that you face?
One is that suppose it's a new product, so we don't have credible information,
Correct.
information to project the future results.
Is your voice breaking or is it my bad?
So that is the main.
Is your
Hello,
voice-
am I
Even I
audible
couldn't
now?
listen.
Okay. No, I think your network is poor.
Okay, 1 second.
Yes, Ankur, tell me, what issues do you face generally?
Yeah, one where obviously where the sufficient data is not available,
Okay.
BCL can give random output.
Okay.
Second is whenever there is a seasonality trend,
Okay.
for those, because BCL uses averaging of 2 years, 3 years, 5 years, whatever you have selected,
Okay.
it may give incorrect projection for that particular quarter because of the seasonality impact.
Okay.
Third would be, let's say many a times, what happens is if you are using paid triangles, and if claims team suddenly decides to close all the outstanding claims and make huge payments in 1 quarter or 1
Right.
month, then your chain ladder will throw a very high reserve.
Good point. Fair point. I'll ask you another question. I'll ask you a more important question. When it comes to paid versus incurred, do you expect the triangle to stay the same?
Sorry. Can you repeat?
I do an exercise, right?
Mhm.
I do an exercise where I use cumulative paid claims. Can you hold on for 1 minute? Can you hold on for 1 second?
Sure. Yeah.
I'm really sorry. It's my wife. I can't cut the call. So, all right. So you run a reserving exercise with paid claims,
Mhm.
right? You run a reserving exercise with incurred claims.
Mhm.
Now, would you expect the results to be the same or
No, never.
okay? Theoretically,
Practically never. Theoretically, yes, obviously.
you have to make that qualification. Theoretically,
Yeah.
it has to be
Okay.
the same, right? Practically,
Yes,
it is never the same. So the question,
correct.
so my question here fundamentally is why?
Because the payments are more dependent on the claims team uh, and or the insurer, whereas the incurred, which morely relies on the reporting, is more related to the customers for reporting the claims.
Okay.
Also, the paid method does not give credibility to the amount that is there in the outstanding while projecting the claims.
Can you repeat that point?
So the amount which has been held as an outstanding reserve
Okay.
by the company.
Hmm.
So no credibility is given to that amount in the paid method, except that it is just subtracted from the ultimate
Fair enough. Basically, delays in making payments.
delays.
Hmm.
Correct.
Fair enough.
So these are main two reasons why it won't be same.
Okay, there are more reasons. Chalo. I'll come to this because the point of the discussion was to talk a little about the issues that are there for the BCL methods, right? Now, there are four main issues that are there, right? The first one is obviously the mechanical generation of link ratios. So most of the time, right, software is used to, and this is strictly from the text, right? So I'm going strictly with what is there in the combined materials pack. I'm not like, there are obviously other issues that are there with basic chain ladder, which we will, which we can add on to. But from a theory perspective, right? I'm strictly approaching this from a theory perspective. You're looking at mechanical generation of link ratios, which is a major issue because sometimes it's generated using software, and software generally selects tail factors based on some kind of development factors and tail factors based on some kind of like an algorithm, right? And sometimes you may have to modify the tail factor or change the link ratios, which is a big problem, right? So that's one issue that is there. The second is the analysis and selection of link ratios, which you guys already mentioned, right? Which is that effectively speaking, you have to analyze the ratios one by one, and you have to understand the reason behind why there are high numbers, why there are low numbers. You need to have a rationale for why that number is what it is, right? And that's a major issue with BCL because it takes time for you guys to understand, right? So if there's a change in the portfolio, then, and if that change results in a link ratio going from 1.04 to 1.1, you have to understand why that happened, right? And that is the entire purpose of reserving, right? So when you do a reserving exercise, that's your job. That's what you do, right? And that's an issue for you, right? So that's one issue. Third issue is link ratios less than 1, right? And why do link ratios less than 1 occur?
So in paid triangle, it could occur because of some salvage amounts
Perfect.
that we have received.
Perfect.
More
Also
often
in
than
incurred,
not,
yeah.
that is.
Why paid also? Why only in paid? Also in
Sorry?
incurred?
No,
Why?
in incurred also, in incurred, it occurs if the claims gets cancelled or closed without payments.
Correct. Correct. But I'm saying that entire point is, don't qualify it as just a paid thing. It's also an incurred thing, right? So can happen anywhere. Because at the end of the day, incurred is nothing but paid plus outstanding, right? So that's one thing. The official answer is reserves are released, right? That release could happen because of whatever your points. You were bang on the money there, right? So link ratios less than 1 is another issue with basic chain ladder. The other one is paid versus incurred that we kind of discussed, right? And theoretically, like I mentioned, they have to generate the same estimate, but practically it doesn't. And the reason, you made a very good point, which was delay in payments, which is a very great point. The second point that you have to understand is that large complex claims often takes more time to settle, right? Which results in a difference between the paid and incurred claim triangles. There could be disputed claims, which could increase the amount of time it takes for claims to be paid, right? Which results in differences. One pattern might be more volatile. For example, paid patterns are generally more volatile than incurred patterns. Do you agree with that assessment?
Yes.
So, and that assessment is because in the early years, because of low exposure and things like that, when you make one single payment, the link ratios will shoot up and down. So that's why the paid patterns are generally slightly more volatile than the incurred patterns, right? Changes to case reserving over time can also change your paid versus incurred. So there has not been a direct question on this. However, it's a very good nuance to understand why paid and incurred are different. So while it has not been examined directly, you can generate a lot of higher order points just by thinking along these lines, right? And when you're writing your answers, right, think about how you do your work in reserving and how that translates to problems that you face. So these are all like things that you have to get from your work, and you would have for sure made reserves for large claims, correct? You'd have done reserving for large claims. You'd have done reserving for cat claims. So you would know how different they are, and you know how they are, how their reserving works versus reserving for, say, attritional claims, right? So this is something. This is like a exam tip for you, for example, for just for the sake of saying it, right? I hope I'm clear there.
Yes.
Okay. All right. Can you quickly tell me what are the pros and cons for basic chain ladder?
I will
Go ahead.
try.
Go ahead.
So the pros could be it's fairly easy to calculate. I
Okay.
think it's a simple methodology.
Good.
Uh, then it uses the past experience to calculate the reserves. We don't have to use complex statistical methods
Every method
or
is past experience.
estimates. Not using any complex statistical
Okay.
tools or
Yeah, but
method, we can do it in
no,
Excel.
but there are easier methods than basic chain ladder. No, there is the expected loss ratio method. That's much more easy.
Okay.
Go on. But you are right. The other points are right. This one point is a little off, but the other points are absolutely right. Go on. You are absolutely right, bro. You're on the right track.
And I can't think of any other pros currently.
Okay. Cons. Let's go with
Uh,
cons. What are the cons?
Won't cons be the BCL issues that we discussed? Some of the issues we can
Okay.
derive the cons from them as well, right?
Fair enough.
So one could be like there could be biasness in judgment. Could that be treated as a con as well?
You could say that, yes, but it's not a con as per the textbook. But yes, you could say that there could be bias in the judgment. Just hold on, am I getting solved? All right. All right. Let's go to the pros and cons section. So you are right, absolutely right. It's easy to explain. Conceptually, it is very straightforward, right? Can be applied to a wide set of data points. So it's not a narrow thing. It is easily modifiable. You can modify the chain ladder method very easily, right? I don't know if I've explained it already. It's conceptually straightforward. It's easy to explain it to non-technical people, right? It is not too time consuming. You can do it in a very fast, you can do it pretty fast, right? It is the starting point for more complex methods. And very important point, which often gets missed out, is that it does not require a lot of compute power, right? It's not like a stochastic method or something where there's a simulation required, where you need computing power for generating, say, 1 million different simulations. Basic chain ladder methods, in fact, almost all analytical methods that are there are this, like it's a very simple this thing for you. It's a straightforward 0.5 marks if you get this, right? Does not require computing power. When you don't have, so this is a good exercise for you to run as well. When you don't have points to generate, right? Remember things like cost of doing something, the amount of time required to do something, the amount of expertise required to do something. So try to approach the answer in those aspects, right? Those soft aspects. Even those will fetch you a lot of marks, right? So let's say that you were supposed to answer this question for 4 marks, which means that if it's a 4-mark question and it asks for pros and cons, you have to, you can assume safely that it is 2 marks for pros, 2 marks for cons, right? Which means that you have to generate roughly 4 points for pros, roughly 4 points for cons. And now you have only 2 points. Now for 2 other points, you can think of points such as whether is it going to be costly? Is it going to be manpower intensive? Is it going to be complicated to implement? Is it going to be, do I need expertise to implement it, right? Do I need to hire separate experts to implement it? These are all valid, viable points for you to write in the exam, right? And this is not just for methods over here, right? It could also be for models. It could be for capital modeling. It could be for, implementing an insurance program. So these are generic points which you can think of beforehand and you can have in your mind, which you can use when you don't have any other points to generate, right? So of course you have to answer the question contextually, right? But you can get like 1 or 2 marks here, which might be the difference between passing and failing. Clear?
Yes.
Okay. Now, cons is fairly straightforward, right? There could be distortions due to unusual experience, and that's very common in any basic chain ladder method, right? Recent cohorts are almost useless because of lack of data experience. And generally speaking, this is more the case in this is definitely the case for long tail lines, lesser the case for short tail lines. For example, motor OD, it only has a tail of 3 months on average, right? Whereas motor TP has a long tail, right? You're talking about years. So when you have only one cohort for motor OD, the most recent cohort for motor OD is still has more information in it than the most recent cohort for motor TP, right? And there must be a lot of care that you have to take when there are unusual features in the data, right? Which kind of messes up your entire calculation. It's not beautiful anymore, right? So those are the pros and cons for basic chain ladder. And we're going to go to the next feature, which is the inflation adjusted chain ladder. Now, can you tell me now you know the basic chain ladder method. What are the assumptions behind inflation adjusted chain ladder? The 3 assumptions. What are the 3 assumptions now? How do they change?
So in inflation adjusted, we calculate the inflation rate. Check the inflation rate of the past.
Correct. But what are the assumptions? What are the 3 assumptions now? How do they change?
So the one assumption will remain the same, that the first cohort should be completely run off. That still remains.
Complete the assumption.
So the earliest cohort in our data is assumed to be completely run off.
But that's
Or
not,
that it should we should be able to project it using the tail factor.
perfect. That is the full assumption. Always remember that. Never say cohort fully run off. You can say cohort fully run off when you're writing a calculation question, right? For example, they give you a triangle and they tell you this is the
Correct.
triangle. I want you to calculate the ultimate figures. In that scenario, you are entitled to write cohort fully run off because you're not adding a tail factor. Your tail factor is 1. However, if they contextually ask you what are the assumptions behind randomly, there's one 3-mark question. What are the assumptions behind basic chain ladder? You have to mention this. Always remember that. Many people miss that out. It's very important. Clear? All right.
Sure.
So that's the first assumption. Good. All right. Second assumption.
The next would be that the inflation adjusted past claims would be a good representation for the future claims.
Okay.
And the third assumption of the inflation won't be required here, but the assumption would be that the fair view of the future inflation is available with us.
Okay. So you got the second one right, but I think you were a little what do you say? You were a little convoluted over there, right? Simple point, right? You just have to say that past development factors and the inflation will remain the same, right? So that's a simple way of saying it. So the first two
Okay.
assumptions don't change by a lot. Third assumption effectively is, instead of saying that past inflation is a weighted average, future inflation is a weighted average of the past inflation rates, you will say that the future inflation is calculated using a separate index, as simple as that. That's the only change.
Oh, yeah.
Right? Now, building the inflation adjusted chain ladder triangle is also similar, right? You first take claims data, you tabulate it by origin year and development year and whatnot, you build it, and it's basically converted to constant money terms. You complete the triangle, right? For example, that triangle could be cumulative amounts, incremental amounts, you complete the triangle. Incremental amounts. I had a brain fart over there. You have to only use cumulative amounts for completing the triangle, right? And then you disaccumulate the triangles and you get the incremental projected returns for each different periods. And then you apply inflation, right? Have you guys done inflation adjusted methods before in your work?
Practically not, but in CT6, yes.
In CT6, you have done. Okay, fine. So on Saturday, we are going to solve a large problem, which will account for inflation adjusted methods. So on Saturday, if you do not have clarity, you will get clarity on this. Clear?
Yes.
Yes.
Okay, perfect. All right. What do you guys know about the Berkowitz-Sherman method?
I have no idea.
Okay.
Even I don't think I've used it anyway.
Okay, so it's not a usage per se. It's basically an adjustment that is made to the chain ladder technique when there are two things that are observed, right? One, when there is a change to the rate of settlement, and two, when there are changes in case reserve adequacy. So if you notice that these things are different, you can use this technique called the Berkowitz-Sherman technique to arrive at the final ultimate figures. Now, what is it? It is basically nothing but restating the paid claims by examining the incremental claim settlement amounts and restating that to the current estimated settlement date. So you will take a look at all historical claims, right? You will look at how the rate of settlement has changed. And for all the historical claims, you will make an adjustment and you will restate claims to the current rate of settlement. And then you will run the triangles again and you will build the triangles. So that is the Berkowitz-Sherman adjustment. There are very few, I don't think there are any questions from IFoA where this has been asked. I don't believe that over the past 20 years, there has been any question on Berkowitz-Sherman methods. However, I think there have been some questions on adjustments to case reserve adequacy and things like that. And you can always mention Berkowitz-Sherman as an answer. IAI, I would not put it past them for, to ask what does Berkowitz-Sherman mean and, like a regular 4-mark question and things like that. So just a note, it's a theoretical point that I'm trying to bring up. Just remember what this method is. Just remember why it's used and when it's used. Clear?
Yes.
All right. Let's move ahead. We only have 20 more minutes. Okay. All right. ELR method. What can you guys tell me about the ELR method? I'm sure you guys have used it.
It's the estimated loss ratio method, wherein we project the ultimate loss ratio that we expect from a portfolio, and using that we calculate the future reserves.
Correct. Now, what is the loss ratio that you use? What's it called?
Estimated loss ratio.
What's it called? There's a name for that loss ratio. It's called benchmark,
Okay.
right? Now, why is it used? Why do you use ELR method?
When we don't have enough data for the
Good,
to create a triangle,
good,
pass credible data, then we use this method,
good. And why do you not have
especially for newly launched products.
perfect?
Newly launched products mainly.
That's a perfect guess, right? So that's a good answer. Newly launched product is what. So that is the depth that you have to look for, right? So it's not just why, like there's no data is a good answer. No data because perhaps product is newly launched is a very good depthy answer. All right. Now, what are the issues that can arise, right? Now, the main,
Now,
yeah,
one
tell
more
me.
thing. So this can also be used when the development, even if we have enough data, but the development patterns are not regular. So, for example, let's say
Right,
um, follower case or reinsurance inward,
right,
where the claims reportings are dependent on other companies rather than other customers or individuals,
right.
which can be irregular.
You are
So
right.
in such cases, we can use ELR.
You are right. That's a fairly nuanced answer. However, I believe that there are reserving techniques that are there just for that, right? You can study
Okay.
about it more in reserving techniques for reinsurance. I think it's chapter 20. I mean, we will obviously cover it at a later point, although it's a very theoretical chapter. But there are reserving techniques that are existing for inwards and outwards reinsurance, which are more
Okay.
appropriate in my opinion, right? But from a practical standpoint, I agree with you there that from a literal practical standpoint, it makes sense. What you're saying is right.
Okay.
From a theoretical standpoint, from an exam SP7 standpoint, you will still get marks, although I would say that you may have to uh, add this up to your existing answer, which is part of the theory there.
Okay.
You'll
Okay.
probably get more marks with SA3, by the way. Huh? If you answer this, if this question appeared in SA3 and you answer this from your work experience, you'll get more marks than what
Okay.
you
All
would
right.
get for SP7.
Understood.
Because SA3 has more weight to your experience.
Okay. Okay.
Cool. All right. So coming back, right? Issues, right? The main issue is with respect to the benchmark, right? The benchmark used could not be, could be inappropriate, right? So you could be using one loss ratio figure and that loss ratio figure might have no connection with what your portfolio loss ratio is going to be, which means that the reserve that you arrived at is absolutely incorrect, right? A second one is the more important and more widely seen issue, which is that your risk profile and your mix, your portfolio mix could be wildly different from the mix that your benchmark has. So perfect example of this is, let's say that you've launched a motor product today, right? And you have no data. So what you do is you are with, let's say you're with Sunil Insurance Company, right? And I am the CEO. I come and I tell, Unnati is the reserving actuary, and I tell Unnati, please reserve for, we are launching a motor line of business. End of this quarter, I want you guys to create reserves, right? And you take a look at ICICI Lombard's loss ratio, for example, it's at 60%, and you say, let's use this as the reserve. Let's use the ELR method because we don't have any data. It's a very small line of business today. So let's use 60% as the loss ratio and let's run it. However, our insurance portfolio, our portfolio mix for motor might be wildly different from ICICI Lombard's portfolio mix, in which case using the benchmark is completely gone, right? Which results in misestimation of loss rate, misestimation of reserves, which results again in over or under reserving. So that's the biggest issue that you face with the ELR method, right? The third one obviously is earnings patterns could be inconsistent, although this is a very theoretical point. I don't practically, at least from an India perspective, I don't think earning patterns are ever as inconsistent as we think they are, right? They're more or less fairly consistent. Maybe the only place where it's not consistent is in the Western countries where there are spikes because of seasonality, right? So winter generally has a spike in claims experience, which results in earning patterns also needing to have spikes. So I don't think it's a very valid or important point for the India context, but it is a theoretical point nonetheless. And again, the fourth point is another theoretical point, which is that target loss ratios could be unachievable, right? So the you might say, okay, my target loss ratio is only going to be 30%, and you might reserve for that, but that might be an unachievable number, which results in over or underestimation of reserves. So this brings us to what is the requirement of the LR that needs to be used for the ELR method. And this is sometimes a very widely asked question in the SP7 paper, right? Which is, what are the features that you need to have for selecting the LR for a ELR method, right? So first point, it has to be a good benchmark. Second point, it has to have a solid, it can be an industry benchmark, right? It can be the historical loss ratios of the company. It is generally a mix of both the company's historical loss ratio and the industry benchmarks that are there. It should also have a solid backing from an underwriter, right? So an underwriter has to sign off on the loss ratio that is being used, and it has to come, there has to be a statement of opinion by the underwriter before you use it in your ELR methods. Clear?
Yes.
Are you guys tired or something? I'm not hearing the yes also. I'm hearing from like a tired yes. And Ankur is generally Ankur, am I boring you or something?
No, 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 no. Don't worry.
Okay. No, I'm just asking. Please let me know if I'm boring you guys, and I can change my method of delivery of points.
No, no, actually, I said yes, but I was on mute.
Okay. Okay. All right. So can you quickly go through and tell me what are the pros and cons of the ELR method?
Pros will be it is simple and
Good.
easy to calculate.
Good.
And then it could be used when sufficient data is not available
Good.
to calculate the reserves. Then the cons could be that misses inadequate reserve or over reserving.
Okay.
Then maybe it is not applicable for all the scenarios. Like we can't use the LR method for all the scenarios.
Okay.
That could be a con.
Good. That's a very good point. That's a solid point, by the way. You can also bring the pros that I mentioned, right? Simple to build, not too complicated, no expertise
Uh,
required.
yes,
Simple,
easy to calculate.
easy to calculate.
No simulation required.
Exactly. So no computing power required, things like that. So these are all like, so they're not going to give you a lot of marks, right? But they will fetch you like 1 mark. Like if you write 4 points, they'll fetch you like 1 mark, which is something that you're looking for, right? It's why do you want to leave that 1 mark on the table? Might as well pick it up by writing these points. As simple as that, right? So you got the pros and cons fairly right. Simple to apply, not time consuming, can be used when data is sparse or when no data is available, no distortions. It'll always, all the answers will be smooth. And cons is fine. Cons also we've kind of discussed to a certain extent, right? It is the numbers are reliant on the benchmark LR that is being used, right? You cannot make adjustment for large claims in this method. It's because the number is just it's just a pull number that's pulled out and just used, right? So, and if past LRs are used, there's a chance that the data is already biased, which means I'll give you a simple example, right? Let's say that you are using the rolling 3-year loss ratio or the loss ratio of the last 3 years for the motor portfolio as a benchmark for your ELR method. However, the underwriter recently has made like a major change in pricing, which has changed your portfolio from an insurer which carries large risks to an insurer which carries small risks. Now your portfolio mix is completely different, which basically means that your loss experience is also going to become different, and your historical loss ratios are no longer relevant to your future portfolio. In this case, if you use ELR method, your reserving figures will be absolutely incorrect. Clear? Which is the bias point.
Yes.
Okay.
Yes.
All right.
Yes.
All right. This is one slide which I've built for Bonnet-Ferguson method, right? How many of you guys have used BF method in your organization?
I have.
You have.
I have.
Oh, you have. Chalo. So you guys know what it is. So what is the BF method?
In simple terms, it is like a weighted average of ELR and chain ladder method.
Perfect. Please remember that in the exam that will fetch you full marks.
Okay.
That's a perfect example, right? Weighted average, or even better than weighted average, I would say credibility weighted average, right? So perfect. If you add credibility as a keyword, you can expect to get full marks there if they ask you what BF method is, right? Credibility weighted average of BCL and expected loss ratio method is the Bonnet-Ferguson, right? How do you guys go about doing it? What are the steps behind Bonnet-Ferguson methods?
So we give so based on our judgment, we give weights to a BCL and the ELR method, and then calculate the reserves using BF method.
Okay.
That is like a simplistic approach that we use.
Okay. No, but give me like a overview of the approach, no? Of the BF method, like the theoretical approach. How do you calculate the Bonnet-Ferguson estimate? So if I give you a triangle, if I give you an incurred triangle, right? And I tell you, I want you to use a Bonnet-Ferguson method to calculate the ultimates for this triangle. It's an incurred triangle, cumulative triangle. Chalo. How do you guys go about calculating it? Tell me the steps you would take.
First, we'll calculate the development factors.
Okay. But even before that, you have to do. I've only given you half the information. I have not given you complete information. What have I given you? I've only given you the incurred claims triangle. I have not given you half of the information here. So even before you calculate the triangle, what is the first question you'll ask me? I'm your manager and I've come to you and I've said, Unnati, here is the incurred claims triangle. I want you to use the BF method to calculate the ultimate loss ratios. What is the first question you'll ask me?
It would be the IELRs that needs to be used.
Perfect.
First.
What is the a priori assumption? What you will tell me, Sunil, you are telling me to run a cumulative claims triangle and you have given me a triangle and you're telling me to run a Bonnet-Ferguson method. The first question you have to ask is, what is the loss ratio? What loss ratio do you want me to assume? Right? So step one of the BF method, arrive at the a priori assumption. And this is another point when you are writing the BF method, when you are calculating the BF estimate using the BF method, always write this as the assumption. Even though they would have told you in the exam paper itself, they would have told you that the a priori estimate is 80%. Regurgitate that into the assumptions. Write it down. saying that assuming a priori is 80%. You have to make that writing down, and that will give you marks. Clear?
Okay.
Okay. So now you have your a priori estimates. What do you do?
So first we will calculate the development factors like we do for chain ladder method.
Okay.
Uh, so now, based on these development factors, for each cohort, we will have the ultimates for each cohort, ultimate claims.
Okay.
Now, for the part which is developed, based on our selected development factors, we will see what should have been the actual losses till that point. So, for example, if a cohort is developed for 2 quarters, then we will see that up till second quarters, based on our development factors, what should have been the actual, what should have been the expected amount,
Okay.
and we add or reduce the difference between the actual and the expected from the ultimates, and that gives us the final ultimate using the BF method.
Fair enough. Fair enough. But generally,
So one way to
one way.
say this,
That's one
and
way
the
for sure.
yeah,
Yeah,
one way.
that's one way for sure. Easier way is what the text says, right? Which is effectively estimate the percentage developed using the incurred development pattern,
ATUF,
right?
actual to
Using the
ultimate
ATL.
factors. Yeah,
Exactly. 1 divided
and that
by
we will
CDF.
use as the weight.
Yeah,
That we
1
will use as
divided
the
by
weights.
CDF. Calculate. No, that will not be. I mean, yeah, that will be used as the weights, but calculate the percentage that's undeveloped, which is 1 minus P, right? And then calculate the ultimates from that, use 1 minus P, and then add it to your current incurred or current paid to get the ultimate. Simple logic. Clear?
Right.
All right. We will do a question on Bonita-Ferguson on Saturday. So my recommendation to you guys is before Saturday, please read up on these methods. Please try to solve a couple of questions, because we are going to solve a couple of exam style questions. Clear? The reason why I'm keeping this this one session dry and theoretical is because I want you guys to I knew that there'll be questions around assumptions and things like that. So I wanted you guys to have a clarity on this, because when we do the questions, I want you guys to focus on exam technique and not the material, right? So today is going to be material, and then the next class is going to be exam technique. Clear? I'm sorry?
Yes.
You were saying something, Unnati?
No, it was not.
Okay. So when do you use the Bonita-Ferguson method? You use it when data is sparse, right? And you can tell me that, okay, data is sparse. Why are we using Bonita-Ferguson and not the ELR method, which is easier, right? And which is a fair question, right? Now, there is another nuance to this answer. The answer is data is sparse, and I want to blend experience and exposure estimates, right? I want to use this data. It's not like I don't want to use this data, right? I have some data. It is immature, but I have some data, and I want to use that into my estimate. And that's where Bonita-Ferguson shines, right? The advantages of Bonita-Ferguson is that it can be used when claims development is very early stage, and it allows credibility to be provided to experience, which is very important, right? I might have X claims today, and I might not want to create an estimate based on just X claims. However, with the Bonita-Ferguson method, I can assign a credibility to that based on my payment patterns, my development percentages, and I can automatically create an estimate from an industry loss ratio, which kind of creates a better estimate. It's a blended estimate, right? It's a blended technique. Now, the biggest problem is it is heavily dependent on the a priori estimate during early stages. And during later stages, that a priority estimate becomes useless, right? So that's one big con. And it is got very limited use in short tail lines where, like you have very quick development. So the moment development is very fast, what happens is that your Bonnet-Ferguson estimate kind of becomes a simple basic chain ladder method. And the point of credibility kind of breaks down, right? So those are the cons for Bonnet-Ferguson. Clear?
Yes.
All right. Now, the next final set of methods is a family of methods, right? It's not just one method. It's a family of methods. It's called the ACPC methods. Now, have you guys used the ACPC methods in your work?
Yes.
Okay, good. All right. So what are the components of the ACPC method? There are two components. There's a separate triangulation of frequency. There is a separate triangulation of severity, right? Now,
Yes.
frequency, there is no single definition of claims. It depends on what you define as settled claims, what do you define as reported claims, what you define as reopened claims, right? So there is no single definition that is there. And for severity, it could be both incurred and paid, right? The method basically is separate components for each origin, right? Separately project incurred claim numbers, estimate the claim amounts, and then add them together. So for you to calculate the ultimate cost, you have to calculate the average severity and the average frequency. Multiply the two, you get the average claims cost. Clear?
Yes.
Now, what are the issues with ACPC? The issues primarily stem from 4 major cohorts, right? And sometimes this can be an answer. This can be a question for like a 3 or 4 mark question in your IFoA exam, right? What are the issues with ACPC? There has been a question on this. First point is with respect to reported claims. The definition of reported claim is very important. And if reserving protocols have changed over time, that estimation can change, right? So it's a very big issue with ACPC. The second is with respect to nil claims, right? Generally speaking, the question that needs to be answered is, does your claim numbers include nil claims? Because if they do include nil claims, your actual frequency figure that you arrived at is a underestimated frequency, right? If they don't include nil claims, my opinion, and this is strictly my actuarial opinion, nil claims should not be accounted for when you're estimating frequency, right? So your true frequency, your true definition of frequency is when it has no nil claims. Clear?
Yes. You said underestimate. Shouldn't it overestimate the frequency?
Oh, I'm sorry. No, it's frequency is nothing but, oh yeah, sorry. I'm so sorry. Overestimates frequency. I am so sorry.
Yeah.
I'm having multiple brain farts today.
No problem.
I'm sorry. Yes, you're right. It overestimates frequency, not underestimates. Yeah, how did I miss that? All right. The next point is with respect to reopen claims, right? The question or the biggest issue with ACPC is how are reopen claims treated? So I'll give you a simple example. And this is a practical example that you probably would have faced. Let's say that client takes a policy in 2023, right? January 1st, 2023, client takes a policy. June 2023, he files a claim. And in October 2023, that claim gets rejected. Now in 2024, he reopens the claim. He goes to the ombudsman. The ombudsman tells the insurer, reopen the claim. Now the claim gets reopened in 2024. And in June 2024, it gets settled. The question right now is, with respect to the reopened claims, where does it go? Does it go to the origin year or does it go to the reported year? Because it got, you understand what I mean by when I say origin year, reported year, right? It might be the same claim, but there are now 2 origin periods for the claim, right? Do you treat that as 2 different claims or do you treat it as the same claim, right? Now, there are multiple insurers who take multiple approaches. So you have to ensure that they don't distort settled claims, because if you account for it separately, this may actually impact your average claim cost, right? Because let's say you take it as 2 claims, you will now divide the number by a larger figure, right? So it impacts your average claim cost. So reopen claims treatment is a major issue with ACPC. And so is the definition of settled claims. You have to clearly define what settled claims is. And you cannot have a willy-nilly definition of settled claims when you're dealing with ACPC, right? Because so at the end of the day, right, when one thing that you should notice is that all the issues with ACPC comes from the frequency side of things and not the severity side of things, right? For most claims, for most policies, for most insurance policies, severity is not a major kind of a driver of issues, right? It's always frequency. Frequency is the most difficult thing to handle. And if you handle frequency, your pricing, your reserving, everything will be spot on, right? And frequency is the hardest thing to estimate as well. Severity is fairly easy to estimate if you have a little bit of data, right? You can very simply, you just need an experienced claims handler and he'll tell you, yeah, for this kind of claim, the severity will be this much. For this kind of claim, severity is going to be this much. So that you can get fairly accurate estimates on severity, right? It's not like a rule, but general kind of trend is that severity is almost always more manageable than frequency, right? Frequency is always the problem child, in my opinion, at least with what I have seen. I don't know if you guys have severity problem childs, but frequency has always been the problem child for me.
Yep.
All right. So pros and cons, right? What are the pros and cons for this? And this is the last slide, and I will leave you guys. I think I've overshot it by 70 minutes, which is where I put 90 minutes there, right? Simple pros and cons, right? Easy to communicate, easy to understand. Those are very important points. You get more info on both claim amounts and frequency, which is the more important thing there. Can be used along with other methods. And it also helps in explaining volatile data. So you will be able to provide more explanation using ACPC methods on why data volatility exists, right? You can say that, oh, yeah, volatility in data is there because frequency is up and down, right? And severity is standard, but frequency has been up and down. So that's resulting in volatility or vice versa. And more importantly, one pro of ACPC method is that it can be used in explaining latent claims. This cannot be very easily done with other methods. For example, say your BCL method and your ELR method cannot be done. But with ACPC method, you will be able to at least provide an explanation for latent claims. Biggest cons, reopen data, like I mentioned, biggest cons, right? It has a distorting effect on the entire triangle, right? So that treatment of reopen claims has to be accounted for. There is a lot more data requirements for ACPC methods because you are splitting the data into number of claims and claim amounts, and not just cumulative incurred, cumulative paid, and things like that, right? So you have more data requirements. If you have smaller data size, ACPC methods will generally provide more volatile results. And there are also generally some distributional assumptions that you make on frequency and severity when you make the ACPC methods, which is not existent in the other methods. As a note, before we end the lesson, always remember that methods are only directional indicators. You will only get directional pointers. No method will give you an accurate estimate of liability, right? These are all directional in nature. And more often than not, if you see even in your own insurance companies and your own consulting firms and things like that, people will always do reserving exercises where they do multiple methods, right? There'll be one master Excel file, and that Excel file will have, like sheets and sheets of data, and the data will keep flowing into, one sheet to the other, everything. Finally, there'll be multiple methods that are there. And the final estimate of ultimate figures will always generally be like either a weighted average of multiple methods or a simple average of multiple methods. Is that happening? Is that an accurate estimate of what's happening in your own companies?
Partially, yes.
Okay.
So while we calculate using all these different methods, so incurred CLM, paid CLM, incurred
Right.
BF, paid BF, ULR, and ACPC.
Right.
But for a particular LOB, we still use different methods on some objective criteria. So
For sure.
recent quarters, so for recent quarters, we may have used the ULR. For the middle quarters, we may have BF.
Yeah,
fairly
for sure.
developed quarters, we might have used CLM.
Yeah, for sure, for sure. But I think
But
that
yeah, but then within CLM, we tend to choose higher of the two, higher of paid CLM or you got CLM, or
correct.
higher of paid BF and
Correct. There will be some logic. There'll be some logic to selecting
Yeah.
the thing, but
some
generally,
objective, some
Yeah.
objective logic. Yeah.
yeah, there'll be some objective logic, but more often than not, you will see multiple methods being used, right? So the logic behind me telling this is that don't get hung up on one method. Make sure you know every method. That's all. All right. You should know every method as an actuary. And there is also one textbook that is there for reserving, which is extremely informative. I will share the name of that book. I don't have the, I think it's General Insurance Reserving or something like that. I'll share the name of that book and I'll give you guys the reference. If you guys can buy that book and if you guys can keep it with you guys, go ahead. If you want to go depth first into reserving, that's the first book that you buy, right? So I think it's General Insurance Reserving or something like that, right? It's a textbook that's there. Let me find out the name of that book and I'll tell you guys. But it's a very good read. I did that when I studied SP7. It helped me a lot, right? So it's got a lot of pointers that are there, and it's not just these methods. There are also multiple methods that are there, right? So it's a primer. It's like the Bible of reserving. So if you can get that, please go ahead and get that. And if you want, it makes a very interesting read.
Okay.
Okay. All right. So during the weekend class, like I mentioned before, please do a pre-read of this again. Do a revision of these things again. This entire PPT, it will get uploaded. Please do a revision of this. And during the weekend class, please be ready with paper and pen. Or Excel for that matter. If you are comfortable with Excel, go ahead with Excel. We are going to solve multiple questions on reserving. And we are going to see one more point, which is how do you calculate UPR? So that's the only point that's remaining from chapter 15. We're going to see that during the weekend. And then we're going to dive straight into calculation. And once we're done with reserving, we're going to go into stochastic reserving techniques. And we're going to spend a little bit of time with ALM. And then we're going to go into the two big topics that are there, which is capital modeling and accounts. Okay.
Yes.
All right.
Yes.
Okay. Chalo. Sorry if I said 1 hour. I again have not kept my word. It's 1 hour 25 minutes. I really apologize. I have to make better time management. But hope this class was informative and see you guys over the weekend.
Yeah. Thank you so much. Thank you.
All right.
Thank
Bye.
you.
Bye.
Bye.